Hello everyone, this is Kulkarni Gaurav giving seminar on classification of signals and amplifier parameters. Today we are going to see some of the points which are shown in the contents. The first one is what is a signal? What does it mean actually? The second point is classification of signals depending upon its behavior. And the last one is amplifier parameters. What are the parameters considered while amplification of signals? Now we will see one by one. The first one is what is a signal? What does it actually mean? A signal is a function representing a physical quantity, and typically it contains information about the behavior or nature of the phenomenon. From a communication point of view, a signal is any function that carries some information. Means a signal can be defined as anything which has something important, some information. We can see in figure the analog or digital signal. The term signal includes audio, video, speech, image, communication, geophysical, sonar, radar, medical and musical signals. Other examples of signals are the output of the thermocouple, which conveys temperature information, and output of pH, which conveys acidity information. Typically, signals are often provided by a sensor, and often the original form of a signal is converted to another form of energy using a transistor. For example, a microphone converts an acoustic signal to voltage form, and speaker does the reverse. Signal alone cannot be read by the user on the display. It has to be converted to some other form. For that, we use some transducer. Classification of signals. How the signals are classified? Signals are classified on its behavior in the nature. It can be classified as below: analog versus digital signals, continuous time versus discrete time signals, periodic versus non-periodic signals, deterministic versus probabilistic signals. Now we will see one by one what is analog digital signals. First one is analog versus digital signal. What is an analog signal? A signal with a magnitude that may take any real value in a specific range is called an analog signal. Analog signal is nothing but a signal which we will get from any physical parameter. For example, like vibration. Vibration of any mechanical system we can read by using analog signal. What is digital signal? A signal with amplitude that takes only a finite number of values is called a digital signal. We can see in figure analog representation of a signal and digital form of a signal. The next one is continuous time versus discrete time signals. Continuous time signals may be analog or digital signals, such that their magnitudes are defined for values of t, while discrete time signals are analog or digital signals with magnitudes that are defined at specific instants of time only and are undefined for other time instants. We can see from the graph continuous time, continuous values, continuous time, discrete value, discrete time, continuous values, discrete time, discrete value. These are some example of a random signal, analog as well as digital signal. The next one is periodic versus non-periodic signals. What is periodic signal? Periodic signals are those that are constructed from a specific shape that repeats regularly after a specific amount of time. Means it will be repeated after a specific interval of time. We can see in the figure below A particular signal is repeating itself after a particular instant of time. What is non-periodic signal? A signal which do not repeat regularly, means it shows some different features than a periodic signal. You can see it from the image above. Deterministic versus probability signals. Deterministic signals are those that can be computed beforehand at any instant of time, while probability signal is one that is random and cannot be determined beforehand. Now we will see some parameters which are very important for the signal amplification, and it is required for amplifier. These are gain flatness, reverse isolation, gain drift versus time, deviation from linear phase, group delay, return loss, complex impedance, gain compression, AM to PM conversion. We will see one by one what are these parameters which are very much important for any amplifier. The first one is gain. The ratio of amplifier's output to the input power is called gain. The ratio of amplifier's output power delivered to a Z0 load to the input power delivered from a Z0 source. Z0 source is the characteristics impedance. For small signal levels, the output power of the amplifier is proportional to the input power. Small signal gain is the gain in this linear region. As the input power level increases and the amplifier approaches saturation, the output power reaches a limit and the gain drops. The large signal gain is the gain in this non-linear region. Means for a small signal, gain will be found in linear region, while for large signal gain will be found in non-linear region. The second parameter is gain flatness. Small signal gain is the gain in the amplifier's linear region of the amplification. This is typically measured at a constant input power over a swapped frequency. Gain flatness is the measure of the variation of gain over a specified frequency range. Reverse isolation. What does it mean by reverse isolation? Reverse isolation is a measure of how well a signal applied to the device output is isolated from its input. The measurement of reverse isolation is similar to that of forward gain, except the following 2 points. The first point is the stimulus signal is applied to the amplifier's output port, and the response is measured at the amplifier's input port. Generally, we apply stimulus signal to the input port and we take the response at the output port. But in the reverse isolation case, it is opposite. The stimulus signal is applied to the amplifier's output port and the response is measured at the amplifier's input port. Gain drift versus time. Maximum variation of a gain as a function of time with all other parameters held constant. Gain drift is also observed with respect to other parameter changes such as temperature, humidity or bias voltage. Means we can find gain drift versus time in some of the parameters like temperature, humidity or bias voltage. Deviation from linear phase. Deviation from linear phase is a measure of phase distortion. The electrical delay feature of the analyzer is used to remove the linear portion of the phase shift from the measurement. This results in a high resolution display of the non-linear portion of the phase shift. That is called as the deviation from linear phase. The next parameter is group delay. Group delay is a measure of phase distortion. Group delay is the actual transit time of a signal through a device under test as a function of frequency. When specifying group delay, it is important to specify temperature used for the measurement. Return loss. The ratio of amplifier's output to the input power is gain. For small signals, output power of the amplifier is proportional to the input power. Small signal gain is the gain in this linear region. Complex impedance. The amount of reflected energy from an amplifier is directly related to its impedance. Complex impedance consists of both a resistive and a reactive component. It is derived from the characteristic impedance of the system and the reflection coefficient. The next parameter is gain compression. An amplifier has a region of linear gain where gain is independent of input power level. That is a small signal gain, which is linear in a small signal gain region. As the power is increased to a level that causes the amplifier to saturate, the gain will be decreased. Means if we increase the input power, the amplifier gain will be decreased. Gain compression is determined by measuring the amplifier's 1 dB gain compression point, which is the output power at which the gain drops 1 dB relative to the small signal gain. This is a common measure of amplifier's power output capability. The next is AM to PM conversion. The amount of phase change generated in the output signal of an amplifier as a result of an amplitude change of the input signal. The AM to PM conversion coefficient is expressed in the units of degrees at a given power level. These are some important parameters which are to be considered while calculating amplifier's output. The signal which should be amplified are calculated by using these some parameters. Thank you.